Hello everyone. In this tutorial I am going to discuss ordinary differential equation or ODE and how to solve ordinary differential equation using Taylor series method. As you know, this is a part of numerical analysis. So before going to discuss regarding the Taylor series method, let us know what is ordinary differential equation or ODE. Now, in mathematics, an ordinary differential equation or ODE is a differential equation containing one or more functions of one independent variable and the derivatives of those functions. Okay, so from here what you have to remember, that is, it is used for one independent variable or the derivatives of those functions. Okay, the term ordinary is used to contrast with the term partial differential equation, which may be with respect to more than one independent variable. So in partial differential equation, we'll have more than one independent variables, and in ordinary differential equation we'll have or we have to work with only one independent variable. Okay, now for this is the standard form of an ordinary differential equation, that is y1 equals to dy dx plus y1 equals to dy dx equals to f of xy. So that is function of x and y with yx0 equals to y0, and we have to find yx, find the value of yx. Okay, and x is any known value. Okay, now in our question in exam, this y1 equals to dy by dx equals to f of xy, it will be given. Also x0 and y0 will be given. Now this x0 is the initial point and this y0 is the solution of differential equation y1, solution of differential equation y1 at the initial point x0. Okay, so at x0 the value of y1 is y0. Okay, and we have to find yx, that is another instance of x, y for another instance of x. Here the instance is x0 at yx0, and we have to find yx. Here this x will be another instance of x0, instance of x. Okay, so it may be x1, x2, x3 and so on. Next, to solve ordinary differential equation, there are Taylor series method, Euler's method, Euler's modified method, Runge-Kutta method of order 4, Runge-Kutta method of order 2, and predictor-corrector method. These methods are used generally as per the syllabus of undergraduation level or post-graduation level. Okay, now let us see the first one, that is the Taylor's method or Taylor series method. And what is it? Now for given ODE, y1 equals to dy dx equals to f of xy with yx0 equals to y0, it is already we have checked in the previous slide. The Taylor series method or the solution of this differential equation is this one: yx equals to y0 plus x minus x0 y1 0 plus x minus x0 whole square by 2 factorial y2 0 plus x minus x0 whole cube by 3 factorial into y30, then x minus x0 whole to the power 4 by factorial 4 into y40, plus dot dot dot. That means the next term will be here, the next term will be x minus x0 to the power 5 divided by factorial 5 y50 and so on. Okay, now where y10 equals to dy dx at x equals to x0 and y20 equals to d2y dx2 at x equals to x0. Okay, now here you can see we are getting lots of instances of y0, that is so lots of instances of y, that is y0, y1, y2, y3, y4 and so on. So how many times we have to find the value of the instances of y? See, we have to find the value of yx using y0, y1, y2, y3, y4, y5, etc. in such a manner that we'll have at least 4 non-zero values for the instances of y. Okay, so whenever we'll get 4 non-zero values for these instances, that is y0, y1, y2, etc., we can stop differentiating anymore. How? See, suppose we have here y0, y1, y2, y3. So suppose this y0, this one, then x minus x0 into y10, then this third term, then the fourth part, all these fourth part are non-zero. Suppose, then we don't have to find this y4 anymore because we have got 4 non-zero elements. Okay, so 4 non-zero, and that is our requirement. I hope you have understood this thing. Okay, so y0, y1, y2, y3, if we get this 4 item as non-zero element, that is the value will not be 0, then we'll stop our operation of differentiation and we'll get the value of yx. And remember one thing, that by this Taylor series method, as we are checking 4 non-zero values, and if we get these non-zero values up to this, if we get, then we don't have to calculate anymore. Similarly, suppose we will get 4 non-zero values after calculating or after differentiating till y5, then also we don't have to find y6, y7, y8, etc. Okay, that means as we are ending our operation at the intermediate term after getting 4 non-zero elements, that's why we'll get the value of yx as approximate value, not the accurate value. Why? Because we are not calculating all the instances of y. We are just calculating till we are getting 4 non-zero instances of y. Right? So let us check this thing with an example. Now here, find the value of yx at point x equals to 0.1 and x equals to 0.2 for the ordinary differential equation dy dx equals to x square y minus 1, and where y0 equals to 1. So this is our question. Now in this question, let us go to the solution. In this question, what is given? Y equals to dy dx equals to x square y minus 1, it is given in the question, right? So y is the differentiation. Again, y0 equals to 1. That means y of x0 equals to y0 equals to 1. We can write from the definition, as we have seen in the previous slide, from the definition of ordinary differential equation, that it is the this 0 is the initial value of x. So initial value of x is x0. So we can write x0 equals to 0 and y0, that is y of x0 equals to 1 as it is given. Okay, so these things are given, and according to this we have to find y 0.1 and y 0.2. So this 0.1 and this 0.2, these are the instances of x. Let us check how to do that. Now, according to the Taylor series method, we have this formula: yx equals to y0 plus x minus x0 y10 plus x minus x0 whole square by factorial 2 y20 plus x minus x0 whole cube by factorial 3 into y30 plus x minus x0 by factorial 4 x minus x0 to the power 4 divided by factorial 4 into y40 plus dot dot dot, and this will be treated as our equation 1. Okay, now after getting this, since y1 equals to sorry, y1 equals to dy dx equals to x square minus y minus 1, this one. So y1 0, that is y1 at x equals to, here y1 0 means y of x0. Okay, so y1 0 equals to x0 whole square into y0 minus 1 according to the formula, that is y1 equals to x square y minus 1. So putting these values, y1 0 equals to x0 square into y0 minus 1, right? From here we are just putting the value of x0 and y0, right, equals to, see, we have these values x0 and y0, we have already these values for x0 and y0. x0 equals to 0 and y0 equals to 1. So by putting these values, 0 into 1 minus 1, that is 0 minus 1, it is minus 1. So y1 is minus 1 and y0 is 1, we have already got. Okay, so let us make a tabular format: y0 equals to 1, y1 equals to minus 1. Okay, now just check y2. What will be the value of y2? y2 is equals to dy1 by dx equals to the differentiation of y1, that is this part, that is x square into y minus 1. Now if we differentiate, as we know, the formula of the product is d dx of uv. Okay, so that means product u into v. So if we differentiate uv, we'll get u into dv, u into dv dx plus v into du dx. That is, first function is u and second function is v, u and v. Okay, if we have this thing, then the differentiation of this will be the first function differentiation of second function, and then second function differentiation of first function. That is, here it is written u dv dx plus v du dx. So u is the first function, v is the second function. Again check this thing: first function into second function's derivation plus second function into first function derivation, right? So here x square y, x square is the first function and y is the second function, right? So if we make the derivation of this, we will get x square into dy dx, and dy dx means y1, that's it. Then second function into derivation of first function, so second function is y into derivation of x square. X square will become 2x after derivation. We know this from our school life. Okay, from the calculus, simple, it's a simple derivation. So we are getting x square y1 plus y square y into 2x minus 1, derivation of 1 is a constant, so derivation of any constant is 0. So x square y2 equals to x square y1 plus y into 2x minus 0. Got it? Now putting the value of x1 y x0 y1 0 etc, let us check y2 0. Y2 0 equals to x0 square into y1 at 0 plus y0 into 2 into x0 minus 0, right? So x0 is 0 plus the value of y1, x0 is 0. Okay, next y1 0 is minus 1, so 0 into minus 1, that is as we have got y1 equals to minus 1, so 0 into y1, it is minus 1 is 0. Again y0 is minus 1, so it is minus 1 into 2 into 0, right? 2 into 0 as it is there, so it is again 0. That's it. Okay, it should be minus 1. So we are getting y0 equals to 1, y1 0 equals to minus 1, and y2 0 equals to 0. Okay, then we'll go for y3, the value of y3. For getting the value of y3 0, we have to calculate the value of y3, right? And y3 is nothing but dy2 of dx, that means derivation of y2. Okay, and how will you get that? See, y2, in y2 we are getting this thing, x square y, that is from here, again here 2xy, right? 2xy from this, and 0 is there, so x square y1 plus, it is y1 plus 2xy. So first we have to find out the derivative of this thing, x square y1, then 2xy. Okay, so for x square y1, the first function will be x square and the second function will be y1. So just from this formula, derivation of u v equals to u dv dx plus b du dx, that is first function into second function's derivative plus second function into first function's derivative. So here we are getting from if we didn't make the derivation of x square y1, so we will get x square derivation of y1, that is y2, and then y1, that is the second function, and derivation of x square, that is 2x. So this we are getting from the first term. Then the second one is 2xy. We have to find the derivation of 2xy. 2xy, it is just 2y1. Similarly here, just like this function, it will be 2y1. Okay, that is y1 into 2 dy dx, that is derivation of x, so it will be y1 only, 2 into y1 into 1 plus the second function v into du dx, that is 2x y1. Okay, so 2x into derivation of y, 2x into derivation of y, that is 2x y1. I hope you can understand it. Okay, so after simplifying this thing, this equation y3, we are getting y3 equals to x square y2 plus 4x y1 plus 2y. Okay, now putting the values of x0, like y3 is 0 equals to x0 square plus y2 at 0 plus 4x0 into y1 0 plus 2y0. Here the product of x0 and here also product of x0, that means both of them will be 0 as x0 equals to 0, and 2y0, we have the value of y0 as 1. So 2y0 is equals to 2 into 1, that is 2. So we are getting the value of y30 equals to 2. Let us check again y4. So we have got y3, till y3 we are getting it is 2. Okay, so y4 is nothing but derivation of y3, that is dy3 dx. Now as we have seen that the value of y3 is x square y2 plus 4x y1 plus 2y. Here it is the x square is the first function, y2 is the second function. So from this, if we derive it, same thing, x square, then the second function, that is y2's derivation, that is y3. Okay, after that the second function into first function's derivative, so second function is y2 and first function is x square. After making the derivation of x square, it will become 2x, so y2 into 2x. Again from this, if we make the derivative, we'll get 4x into derivation of y1, that is y2. Again y1, 4y1 into derivation of x, so it will be 4y1 into 1, and 2y. So after making the derivation of y, we'll get y1. Okay, so after simplifying this y4, after simplifying this line, we will get x square y3 plus 6xy2 plus 6y1. So putting the values of x0 and y0 and other things, we are getting y40 equals to x0 whole square, x0 square, y30, 6x0 y20, and 60x0 y20, and then 6y10. Okay, as you can see, this is the product of x0, this is the product of x0, so both of them will be 0, and this is equals to y10 is equals to, as we have seen, the value of y10 is 1, right? 1. So from here we can write it is 0 plus 1, and that is equals to 1. Okay, so we are getting 6 into minus 1, y10 is minus 1, it is minus 1 into 6. Let me write only this thing, 6 into minus 1. So what will be the value? It will become, it will become minus 6, right? So we are getting y4, the value of y40 as minus 6, right? So as a whole, we are getting all these values, y0 equals to 1, y10 equals to minus 1, y20 equals to 0, y30 equals to 2, y40 equals to minus 6, and as we know, this is also given, that is x0 is 0. Okay, so by Taylor's method, we are getting this formula and putting the values of y0, y10, y20, y30, y40, and also x0 is 0, right? We are getting this thing, that is y0, here it will be minus 1, y0 is minus 1, I think, y0 is 0, y0 is 1 plus x minus 0 into minus 1 plus x minus 0 whole square by factorial 2 into 0, Again, x minus 0 whole cube by factorial 3 into 2 plus x minus 0 whole to the power 4 divided by 4 minus into minus 6. Okay, so how many times we should check the values of this how many times we have to make the derivation of y. See, from here we are getting y0 as 1, y1 0 as minus 1, y2 0 as 0, y3 0 equals to 2. So if we make the derivation up to y3, see, we are not getting 4 non-zero element. We are getting only 3 non-zero element, that is y0, y1 0 and y3 0. As y2 0 is 0, so we have to go for another one, that is y4 0. As we are getting y4 0 equals to minus 6, that means it is a non-zero element. So after y4 0 we are getting 4 non-zero elements. Those are y0, y1 0, y3 0 and y4 0, right? So we can stop our operation here, and that will be the solution for the given differential given ordinary differential equation. Okay, so here after putting all the values of y0, y1, y2, y3 and y4, also for x0, after simplifying the equation, we will get yx equals to 1 minus x plus x cube into 2 by 6 minus 6x to the power 4 by 24. And after that, after simplifying more, we will get yx equals to 1 minus x plus x cube by 3 minus x to the power 4 by 4. And this will be our solution for the given ordinary differential equation. Now, one thing we should remember, that this solution will give us the approximate value of yx. Why? Because here you can see we are considering the values for y4 0 only, till y4 0 only, and after that we are not considering, because we need only 4 non-zero elements for non-zero instances of y0 y, that is y0, y1, y2, y3 and y4. Among them we want only 4, and we are already getting that. So we are not bother about the y5 0, y6 0, y7 0 and so on. And as this is infinite series and we are taking only 4 instances of, or 5 instances for calculating the value, so always we'll get the approximate value or the approximate solution for yx. Okay, now coming to the next, you can see the question that find the value of yx at point x equals to 0.1 and x equals to 0.2 for the given ODE dy dx equals to x square y minus 1 at y0 equals to 1. Now from the previous equation we have got already yx equals to 1 minus x plus x cube by 3 minus x to the power 4 by 4. Now putting the value of x as 0.1 here in this equation, we will get y 0.1 equals to 1 minus 0.1 plus 0.1 into 1 cube by 3 minus 0.1 to the power 4 by 4. And after calculating, we will get the value as 0.900305. And also remember, this will be the approximate value or the approximate solution for y 0.1. Again, y 0.2 as asked in the question, that means x equals to 0.2. So putting y 0.2, we'll get 1 minus 0.2 from this equation. From this equation we'll get 1 minus 0.2 plus 0.2 whole cube by 3 minus 0.2 to the power 4 by 4, right? And after calculating this equation we'll get 0.80227, and this will be also the approximate value. So by this way we can solve an ordinary differential equation using Taylor series method. Hope you have understood the method clearly as well as the example. If you have any query, you can comment in the comment section. I will try to answer all the questions. Thank you so much for watching.